Okay, welcome to JC Connect. In the previous class, we were discussing about the different types of water treatment process. So there, we have already discussed the screening. Um, there, the screening units, we have mainly two types. That is fine screens and coarse screen. Of course, I have mentioned what will be the size of the screen also. What will be the distance in between the parts which you are providing in the screens. Then also we have discussed the bar screen. Normally we will provide the bar screen for water treatment process. So later we have started with the aeration process. So this aeration process is also very important for the removal of undesirable gases like carbon dioxide, hydrogen sulfide, and it also removes the organic matter. Then we were discussing about the Cascade Aerators. Uh, the Cascade Aerators also you can call it as a stepped aerators. You can see in this diagram, okay, the water is entering from bottom here. Here on pipe will be there inside. You cannot. It is not visible. Okay, so then it will start from here. It will start overflowing like this. Okay, here you can see the steps. These are the steps. They're nothing but the steps. So that we have seen. Maybe the design considerations we will discuss later for all, even for the screens, even for aeration, how exactly the design can be done. Then here also this is one more type of the steps aerators. So here you can see that the water is flowing on the steps. These are all steps. So thereby it is exposing to the atmosphere. So once it is going to expose to the atmosphere, definitely the water level uh, is or the water quality is going to increase. Even the oxygen, dissolved oxygen that is present in water, that is also going to increase. And make sure that one very important thing you have to always keep it in mind that um, oxygen should not be more. See, maybe this point I already discussed or not. See the temperature versus dissolved oxygen in water. The highest dissolved oxygen that you will get in water, that is 14.2. Dissolved oxygen is nothing but the oxygen which is going to penetrate into the water, or it is dissolved in water. Oxygen dissolved in water, that we can call it as dissolved oxygen. So this is 14.2 milligram per liter is the highest you will get it. So this is it is in at 0 degree centigrade, and these are both are this temperature and DO, they are all inversely proportional. Means as temperature go on increasing, the DO will decrease. So like that, it will be there. So 14.2 at 0 degree centigrade. This much is very dangerous for our health also. Okay, normally if it is 7 to 8 at the temperature of 35 degrees centigrade, is a little bit, or it is definitely okay for our body. So that always you have to think in the as a human health point of view. Um, Make sure that you should not be exposed to the atmosphere. So that is a kind consideration is that many times what will happen is that okay, it has to be exposed to the atmosphere, that is there, but always on the other side we have to take this. Always you have to think that it should not be more. So this is one you can see the water is, uh, of course, the water is coming here and it is flowing here in this direction. So you can see clearly the steps here. Okay, here these are the steps. Okay, slowly it will fall. Whenever it will fall, it will expose to the atmosphere. Here also you can see the steps, all steps. Okay, sometimes it will be circular in nature most of the time, but you can go ahead with this diagram also. Here it is, till here it will be flat, here also it will be flat. So then slowly we move on to the next type of process, that is uh, sedimentation process. So we already completed the screens, and we completed the aeration, except the problematic part we are not considered. That we'll see later. Problems will take up later. The screens, we are going to remove the big particles and a small sand type of or silt type of, that can also be removed in fine screens. Then aeration, we are going to remove the carbon dioxide, hydrogen sulfide, and other gases, even the manganese, iron, excess of iron, excess of manganese, and excess of Mg. That is, that also we are going to remove in the aeration process. Next, move on to the sedimentation process. Then in sedimentation process is um, before that we have sedimentation, and one more is there, coagulation. Most of the time, now these two are of course different process, but both are interlinked. Both are interlinked. See, whenever the coagulation process, I have already explained how exactly the small information I have already given before starting of the class. Um, Coagulation, of course, colloidal particles. It is completely related to the colloidal particles. That is completely related to the colloidal particles. Colloidal particles. These colloidal particles will not settle under the influence of the gravity. What you have to do is that you have to make it settle. How we are going to make it settle? The only method, you have to add some external agents to the during the process. Then what you have to add? You have to add coagulant. This information I have given. Okay, once you add the coagulant, then once you mix it, then automatically the solids, colloidal particles are going to settle. Then again their sedimentation process is going on. Okay. Sometimes we will put this unit as first and later we'll put the sedimentation process. Sometimes we'll go with sedimentation process, then we'll go with the coagulation process. So we'll start with the sedimentation process only, because sometimes some particles will escape from the screening process. Some particles will always from escape from screening process. So then that particles will be settled in this sedimentation process. So in the screening, what will happen is that most of the time, even you can ask the question in other way also. Here also sedimentation under the influence of gravity, but there we are not giving any retention time, proper retention time in the screening process. Just to go back to the previous screening process here. Here we are not giving any retention time for the water to stand here. Okay, like this always it will be there. Screenings, it will go with some velocity only. It is like what, just screen. It is going to screen it. We are not allowing to settle particles here. Means normally we called one word called retention time. Retention time is nothing but um, water is allowing for some time to stand at this point. At this point we are not allowing to stand here. But in process of sedimentation, we are allowing the water to stand for some time. Okay. Then how much time normally we are providing in sedimentation process? So it is depends. So normally it will stand from 5 to 30 minutes sometimes, or it is 5 to sometimes 1 hour. Depends on the characteristics of the sediments. Some of the sediments will settle under the influence of the gravity soon. For example, sand. If sand is there, then automatically within just or put a sand in you take a conduct a small experiment. Okay, so take a sand particle here, fill up to the water here, then put the water here, put the sand here, just drop it from the top. So immediately it will settle. So this is very fast. Within a 5 minutes, definitely it is going to settle. Then take a chalk powder, or you take the powder what is in your house. Okay, whichever the powder you will use it for your faces. So that you take it and you just try to put here. It will not settle so easily. It will take its own time. That is also solids. That is also one kind of solids. If you want to make that, again you have to add some external agents like coagulant. You have to add it. Okay. So the difference between the screening and the sedimentation is that there we are not providing any retention time to stand for a long time. But here we are providing some time to uh, stand the water and to settle the sediments in that tank. So sometimes the most of the solids will escape from the screening unit. That can be settled or that can be removed in sedimentation process. So the sedimentation is the process of allowing the particles in suspension water to settle out of the suspension under the effective of gravity. Of course, here the principle we are following, that is the gravity. The particles that settle out from the suspension become sediment, and in the water treatment it is known as sludge. I already said that the sludge word I used it during the sludge processing part whenever I'm explaining it. These particles will settle under the influence of the gravity. So once it is settled, it will be taken out. That is that whatever the sediments which is going to settle, that part we is known as the sludge. When a thick layer of these sediments continue to settle, this is known as consolidation. The consolidation is nothing but, for example, during this process, what will happen is that, so you have many particles are here. Just throw it to an tank or just apply it. Some particle will settle soon. It will create one layer at the first time. Okay, at first time within a 5 minutes you can take. Within a 5 minutes, some particles will settle and it will form one layer here. Okay, and some more particles will settle after 5 minutes. Again, it will form one more layer. Then slowly what will happen is that after some time, this layer, the first layer and the second layer, this is first layer, the second layer, they are going to come closer and it will start compressing. It will start compressing or it will start consolidation. Consolidation in the sense clubbing of or making close together with one or two layers, okay, by providing an extra time. So
Later, what a thick layer it is going to form, that is nothing but consolidation. When consolidation of sediments or the sludge is assisted by, sometimes it is we are going to do it by mechanical means, or sometimes we will give sufficient time to settle it.
So then this process is known as thickening.
Okay. Thickening always, if it is not, for example, even after 3 or 4 hours, if that two layers are not coming close together, then we have to make it settle, or we have to give the sufficient for the thickening, or by making with the mechanical means. What you have to do is that you have to make it come to close to together. Then after some time, even mechanical means within 10 or 15 minutes, it is going to come to close together. Then in normal thickening process, if you are doing, okay, that we can call it as sludge thickening, you have to provide longer time. Sometimes 3 4 hours up to 6 hours you have to provide the time for thickening. So this overall process we can call it as the sedimentation process. So then overall, in sedimentation process, we are providing the sufficient time for the particles to settle. That is the first one. Then it will go the consolidation process. So once it is going for the consolidation process, then once it is over, then again that two layers are going to come to close together. Then the thickening process will start. Okay. Initially consolidation, then it will go for thickening. So once the thickening means all the particles will be
Settled at the bottom here and it will be compacted. Or sometimes they may will make some provisions whenever the tank which we are going to discuss. Okay, we will discuss um,
um, that how exactly that will be taken out, in what part of the tank it will be considered. So then the in the sedimentation process, different types of settlings are going to happen.
then which are those uh, types of settling. The first one, that is a discrete type of settling. Discrete. Second one, flocculant. Then hindered. Then this one is compression. This one we can call it as type 1 settling, type 1. This is 2. This one is type 3. And this one is type 4. So in discrete, what exactly normally, initially what will happen? What you can do, um, you take for this, if you want to study how exactly this settling is happening. Normally, there's all four types of settlings are going to happen in most of the sedimentation process. Of course, sometimes some process will not happen. Of course, this will not happen most of the cases. That I'll tell how exactly it will be. Okay, so you take around 10% of sand, around 20% of silt, and around 30% of stone. Okay, or you can take, you already know aggregates. You can take aggregates. You can take some part of powder. You can take chalk powder itself. The chalk powder 75 micron passing. And take, you can take remaining percent. You can 40% powder, 30% stone or aggregates. Aggregates, let it be 4.25 mm, or can take 100 mm, only 30%. So 100 mm is nothing but it is just uh, once 10 mm you can take, not a problem. Only take 10 mm size of the stones or the aggregate. Okay, that you take and mix it well first. Mix it well. Then mix it well and or you can take first bucket, or you can take one this kind of pipes which is let it be a transparent pipe. Transparent pipe. Make it of acrylic sheet. Acrylic sheet. You'll get acrylic sheets. Acrylic sheets. So mix it well and just put it in that um, acrylic sheet type of water sheet containing the water. The first which is going to settle, that we have to consider it. So normally this sand and stones, definitely it is going to settle at the first. Okay, here once you throw it to an the tank, normally sand particles will settle or the aggregate particles will settle immediately. Okay, this settling we can call it as discrete particle settling. This is the first type of settling. Immediate will start here. Okay, very few particles will immediately it will go on. This is the first type of settling. Always it will happen. Okay, so what is the what is the meaning of discrete? See, this the particle shape or size, it is not going to change during the settling process. That we can call it as discrete particle settling. Its particle will now, for example, sand particle, that size always it will remains the same. If you take a stone of 10 mm, that particle shape will always remains the same, as well as this size also it will remains the same. Okay, that discrete settling is nothing but it is a process of settling where the size and the shape of the particles will not change. Okay, immediately the first it is going to settle. Okay, within 3 or 4 minutes definitely it is going to settle. Then second one, sometimes what will happen is some particles you can take silt, or you can take some of the powders. Then these particles will not settle, but slowly after 10 minutes, okay, slowly at the second zone it will start settling. Okay, slowly that particles slowly that particles will settle after discrete particle settling. So then you can see here, okay, here the particles are very fast moving, and okay, very few particles are here, and here you can see the number of particles are more. Here the number of particles are more. Slowly these particles will settle after discrete particle, and the time it will take, it will be more. Then that particles we can call it as the silt and chalk powder. It is going to settle. When it is going to settle, that we can call it as flocculant settling. So normally flocculant means uh, some size of the particles or some shape of the particles. They will uh, make try to make. It is not exactly making. They will try to make and separate a layer here. It is just initial stage of making the layers. That is normally we can call it as flocculant settling. Then it is just starting of the creation of the layers of these particles, what is silt or chalk powders. Then hinders are shown here in this portion. Here you can see the clear creation of here you can see the clear creation of the zones. Like, okay, here assume that in silt and chalk powder, assume that you have 100 micron of 15% and 150 micron of uh, remaining 50%. Then what these two, if you mix, first you mix silt and chalk, okay, let it be 100% combining with 100%. Then you take 100 micron of 50%, okay, they are containing 50% of 100 micron and 50% of 150 microns. Then in this hindered zone, what they will do, that they will create separate zone here. They will create separate zone, and this will also create separate zone. In the flocculant settling, it is just starting of the creation of zone. Here, the hindered or zone settling, here complete the creation of zone is going to um, observe, and you can see the separate layers in this hindered or zone settling. And in compression or the last, we can see that these two layers are going to compress. These two layers are going to compress, and it will make it as only one layer. Okay, here you can see that. Okay, it's all compressing at this point. Okay, so and you can see the as the time progresses in the graph scale, as the time progresses, okay, as the depth is go on decreasing as a height or depth in a single column, you can see the this kind of situation in all this column. Okay, so this is about the different types of settling. So first one, discrete particle settling, where the particle shape and the size is not going to change. Flocculant settling, it is just a creation of the zones just before the creation of the zones. In hindered, it is a creating of the zones different based on the type type and shape of the particles. And compression, the layers which is created in the hindered zone, that is going to tell. Okay, this is complete about the types of settling. Even if you can conduct an experiment in your house during your free time, whatever the combination what I said earlier, if you can take and if you do it, definitely you will get this kind of graph. Okay, so as the depth is go on um, decreasing from top to down, okay, from here to here, you can see the kind of settling in this process. So overall, we can call this as a sedimentation process.